Hi everyone, thank you for joining my talk about Terraform practices in the ScyllaDB Summit. So Terraform is a great tool, right? It is used widely across the world, and this talk will cover not only specific bits and pieces regarding Terraform usage and practices, but also, hopefully, will make you think about your unique use cases and scenarios and help you see the big picture and utilize Terraform in a broader context rather than just an infrastructure as code tool. So that way you will be able to scale up your infrastructure and your teams that will use Terraform. So first of all, a little bit about myself. Hi, I'm Hila Fish. I'm a senior DevOps engineer. I have over 15 years of experience in the tech industry. I'm a DevOps culture fan. I think this is what helps companies achieve great things. I am a AWS community builder and HashiCorp ambassador because I talk about Terraform quite a lot. I also help organize conferences in Israel where I live. The main one is the DevOps Days TLV, which, if I'm not mistaken, it's the biggest DevOps Days event in the entire world. I'm mentoring courses and communities, and on my spare time, I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. So, Terraform. Let's set up some disclaimers here. I'm gonna show here examples from mostly from AWS provider, but of course Terraform works in all with all cloud providers. And I only worked with Terraform open source. Yeah, there was a license change to BSL. I'm not gonna delve into it now because I don't have much time. But I used the open source /BSL one and not Terraform Cloud or Enterprises. So all the examples and practices that you're going to see here are about that. Maybe things are implemented differently for Cloud and Enterprise, so just have that in mind. First thing that I want to cover here are using variables versus locals. So just to set a baseline here, this is assuming that you already use Terraform, you know how to do things, and this is just to improve your usage of Terraform and to leverage its abilities. So for variables and locals, unlike variable values, local values can use dynamic expressions and resource arguments. So locals also don't change values during or between Terraform runs, such as plan, apply, or destroy. And you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. As you can see in this example here, I have variables for project and environment. I have a local that put them both in required tags, and then I merge the tags of required tags that I have here plus a resource tags that I have elsewhere. And then I have one definition of tags and I use it throughout the model, which is awesome because I define it once and that's it. So for a module side, how to use variables, their purpose is to basically be a setting for the module config, but make sure you set up default or validation. And why is that? Because if someone will use that module and not going to pass a value for that variable, then the module will break and too bad. So either set a default or validation. You can see here example of how to set up a validation, and then you are covered in that font. On the module side, for locals, use them as a constant to be honored or relied on. So for example, if I have a module that I create for a creation of buckets, I can set up a local of a bucket name that consists of, for example, my company name, because as we know, buckets in a cloud provider are unique between all accounts out there. They have to be unique throughout entire AWS, GCP, etc. So if I set up a bucket name convention on the bucket side, on the module side, and then it has the company name inside, then we know that everyone that will use this module are bound to have a consistency of the bucket, which is awesome for us because we want consistency. We want to have everyone use it the same way. So this is one example, and just one note about this specific example. If you set up anything related to things with limits, like characters limits, for example, think about any limitations on the cloud. So if you set up a bucket name, think about any characters limits, etc. So this is something to just have in mind. On the live side, and when I say live, I mean where we call the models. So models is what we define to call, to use, and then the live is where we actually call the models and use them. So on the live side, for variables, If you use them once, just set a default and that's that. If you use them per region or etc., then consider using a tfvars file. I'm not going to talk here about TerraGrant, but TerraGrant is also an option to leverage Terraform when you use it in order to reduce code repeatability. Just here, I'm going to mention tfvars as a good option if you don't have TerraGrant. For on live side for locals, you should try avoid using locals as much as you can because we want to make the live side as simple as possible and leave the logic to the module side. So try to avoid it, and only if you have to, then use locals. And consider leveraging data sources to pass outputs to modules, because that way you can have the values of anything that you need pulled out dynamically, and then you know that every time it will be consistent and up to date. So that's about that. So to summarize some things about variables and locals: use tfvars whenever necessary. Some more things to consider is to utilize environment variables if you have them, because if so, it will avoid the need to create more variables that you need to maintain. Treat locals as the hardcode one-time names, decrease code repeatability, etc., and try to keep things as generic as possible. The bad thing is Terraform allows you to have multiple locals block. If it's not necessary, don't do it, because it will be hard to read and make sure that you know where to define where things, and it's just too much to have. So if you don't have to have multiple local blocks, try to avoid that. Decentralize vars, the same reason. Don't scatter them between files. Have one file, and we will have a section of files in this presentation in a bit. And ignoring environment variables, you know, why you can utilize them and have less variables defined. And the ugly thing is to have hard-coded vars values when not necessary, because that's the meaning of vars. They need to vary. So just try to avoid hard-coding values if it's not necessary. Next up, as I mentioned a minute ago, file structure. How do we structure our files in a module or on the live side? So we can take example from a community standard. Community is basically all the modules that we have on the internet. Probably the most relevant ones that you know are Terraform AWS models by Anton Benko and Brian, and I don't remember the last person. I'm sorry, Anton, forgive me. But yeah, these guys are awesome and maintain the Terraform AWS models for everyone, and we can definitely take example from those models to structure our own custom models and our live side. So you can see there that we have main TF, variables, data, and versions or config TF. So main TF is where we keep the main substance of the module or the live side. Variables for variables, data for data sources and providers, and config is for if you have, I hope you have a remote backend to keep your state elsewhere. This is where you define it there. And also the Terraform versions, Terraform provider versions, etc. So that's about the file structure. And if you have other peripheral things that are related to the main logic, they should be kept in separate files. So for example, I have a module to create a VM. I will keep it in main TF, but then if I have a load balancer for that VM or a security group, then I will put them in different files for the sake of logical breakdown. And also in terms of, let's say you created a custom model which is quite complex, you should think about breaking it down to sub or nested models in order to have, again, logical breakdown and to be able to utilize the sub models independently. So for example, if we take a community here as well, the VPC module has a sub module of VPC endpoint, and the EKS module has a sub module of node pools. And it makes sense, right? Because I want to create a cluster once, but then I want to create more node pools. So why should I call the entire module if I can just call the node pool ones, and that's it. So also in your custom models, try and aim to break down models as much as possible, because that way you can call them independently, and then you wouldn't have also a gigantic variables file. It will be only for the relevant models and submodels. The next thing that I want to cover here is applying classic code best practices on Terraform. This is a especially close to heart topic that I like to share with people because I'm not saying that Terraform is a pure programming language. I think that everyone knows that Terraform is not a pure programming language, but similar rules of running code apply to Terraform as well. Terraform progressed over the years in a way that adopts code best practices. For example, before version 0.13, you couldn't use for each for modules, and with Terraform 0.13, HashiCorp finally introduced the ability to loop over modules with a single module call. So that's a really good reason why you should apply classic code best practices on Terraform as well. And what does it mean? Keep the code in source control management like GitHub, Bitbucket, or whatever you're using. Keep it simple as much as possible. Do not repeat yourself if you don't have to. Even functional programming principles can be applied on Terraform. The code, of course, have to be idempotent. And in regards to human and clean, I want to mention and a great article that I usually reference in that point by Thyssen Uhr. We will have a reference slide at the end, so you can have a link to it and read it. I really recommend to read this article. And he say, and I totally agree, that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate. If used correctly, it will just get executed, and that's that. But since human beings are the ones to maintain this code, we need to make sure it is readable. And refactoring and clean code and naming conventions, etc., are invented so that we human beings can read the code better for the sake of us humans and not for the computers. So that's why you should really also aim to have the code as human and clean as possible. Do not overcomplicate things if it's not really needed. Even if it's needed, put a doc string to explain what you did there, and just make sure that you know that human beings needs to be the ones to maintain this code. Okay, before I get to the next point that I want to cover here, I want to throw this question at you, which is basically to think, how do you envision the infrastructure and the company's needs? You should always think things through, and planning ahead will allow you to enable others on anything. In this specific manner, it's about the Terraform journey. And planning ahead will allow you to set up guidelines and best practices of your own, like tagging usage, structuring models, and the TF utilization by others. Again, in this context, but you could definitely and should definitely take this question to anything that you want to implement in your day-to-day. And so in order to emphasize this, I want to share a short story about that. So we had to work like this. We have sync meetings, but we have this innovation meetings where we think about current implementation of infrastructure and how, if we should change things. So I'm in the data engineering group. We have Trino, Apache Trino installed, and it's installed with EC2s and autoscaling groups. And someone from the team raised, hey, let's move Trino to Kubernetes. And then all my team members were like, yes, let's move to Kubernetes. They were very thrilled on this opportunity. And then at that point, I'm like, okay. And this was a conversation between me and myself. Okay, I didn't say anything yet. So I'm like, okay, I want to move to Kubernetes because Kubernetes is a very used platform in everywhere, basically. And if I will work more with Kubernetes, because I have a previous Kubernetes experience, but Kubernetes is very complex. There's no such thing as a tool like I have enough experience. So if I will work and get back to working with Kubernetes, it will be good because it will help my career. I will be more attractive for other employers, bring the necessary experience, and that's that. But at that point, I shouldn't think about myself. I should think about the application and infrastructure needs. Okay, so at that point, again, all of this conversation was very quickly in my head. But what I actually said in the meeting was, wait, before you jump the gun, let's understand if Apache Trino even supports Kubernetes, if it's based on application needs, if the application really needs to move to Kubernetes and not just something that we want to do, etc. So this is, again, very general for being a good engineer in my experience, but let's see how it applies to Terraform here. So since we planned ahead, since we thought things through, we decided to use Terraform and its structure that I'm gonna share here in a way that made sense to us, and I believe that will make sense to you as well, if infrastructure and team scaling is something that you see when you envision the infrastructure and company's needs. So there are a lot of ways to structure Terraform codebase. How do we do that? Let's see how we have it structured in my company. So this is the structure that we have: team, project, cloud provider, account, environment, and region. How does it look like? Like this. So we have the modules. Let's leave it aside for a second. And then on the live side, we have BI for team, Airflow for project, AWS for cloud provider, production or dev or whatever in account or environment, and then use East1 for region. So this is the structure that we have. Why did we choose to go with this structure? Let's go over the reasons. First of all, Terraform is a platform. Okay, so in that way, we have one repository for all Terraform code. All teams can onboard on the same repository, which allows us to set up a standard for the entire company. Everyone can use it, utilize the code as is, and we don't have scattered repositories. It's a standard, and that's that. Also, we leverage code owners' usage, because if we set up, we have it based on teams, the structure. Then we set up the relevant teams on each team folders, and then they have full autonomy to manage their own infrastructure. And this is the way to go, because even though it's in the same repository, all teams can manage their own code. And by using the same repository, all teams that onboard to that repository gets out of the box custom models to use, and because as I showed you before, it's in the same repository, and practices enforcement, tests and checks that can be done on everyone's code to make sure the code is in a high quality state. And I will cover it more in a bit. So this is one reason why we did it. Another reason is to have small Terraform states. This is the structure I'm going to remind you here. The state file is kept in this level. What does it mean? I really hope that you know that how Terraform works. It creates dependencies between resources. And whenever the state file is big, so is the possibility to have invalid dependencies. So if we have a small state file, it eliminates big blast radius and minimizes invalid dependencies. And I had very previous cases where I had a very huge state file. I changed the tag, and then I ran a plan, and then it was about to destroy a resource. I'm like, what? They just changed the tag. What's going on? So this could definitely happen. Invalid dependencies could happen. And in order to avoid Terraform to create invalid dependencies, we should help it by having a structure that enables small Terraform states usage. Let's talk a bit about workspaces, again, in the open source area. So workspaces isolate their state. So if you run Terraform plan, Terraform will not see any existing state of any other workspaces. When to use it? When you have the same Terraform config for different customers, like AWS accounts or different GCP projects. So basically, this is how it looks like. Each account will be in different workspace. Coupled with that, let's say multi-tenants. We have a financial service, login service that should serve all customers. Then these can also be in a workspace of their own, same service in different regions. Some notes about workspaces though. Consider using a Terraform wrapper to avoid human errors, because that way, how do we use workspaces? With the CLI, Terraform a workspace select X. If I forgot to do the select, production incident. Okay, so try to avoid human errors by using a Terraform wrapper that will apply things on the workspaces for you. When using workspaces, you have also less visibility, because unless you use the conditional of Terraform workspace, you don't even know that you have workspaces. And even if you do Terraform workspace select a Terraform workspace list on your CLI, you can see a lot of workspaces, but it doesn't mean that they are in use. So you have a lot of less visibility to consider when you're using that. And also data remote state usages could be problematic while you want to reference other states. So have that in mind as well. Useful workspace usage, like a side branch, you create a workspace, apply your changes there, see that everything is good, and then apply it back on the default workspace, which is your production. So structure your Terraform codebase in a way that will allow small state file setup and Terraform as a platform. If you don't think about how you structure the code base, then organization changes can affect your code structure, which is not great. And if you are using wrong workspace usage, this is not also great. And again, really ugly thing that could happen, huge state files will definitely create invalid dependencies and big blast radius. So always try to avoid that. Terraform execution, I'm running out of time, so I will brief into it. Aim to remote execution, to apply with a plain file to make sure that you know exactly what you're applying, and to set up Terraform timeouts that will avoid you from running Control-C on your machine if you are running on your machine and not remote, which could mess up your state. I did it like when I just started out with Terraform. I don't know if they fixed this behavior or not, but I don't want to find out. So that's about that. Always trying to aim to Terraform execution because we want to make sure that we have other things that handle it for us. I will mention Atlantis in that regard in a bit. And last but not least, practices enforcement. Models should always follow practices of readability and cleanliness of the code, but also you can set any guidelines that you want to enforce, like alert FinOps that if infra cost is more than $10,000, for example, and in order to keep that in check, you should use enforcers. So how do we do it? Let's take example also from community standard. This is from the Terraform AWS autoscaling module. They have checks there that check if the code was formatted with Terraform FMT, if the maintainer added documentation, and if the code actually works with TF-lint. So this is something that you can definitely apply, and then your code will be in a higher quality. So practice enforcement could help with, you can set them up with pre-merged linters, formatters, and logical checks. You can do it with GitHub Actions and CI pipeline checks, have Slack bot drift reporters if you have a drift, or if you have 100% of Terraform remote execution, like using Atlantis, which is a pull request automation for Terraform, then you know that your main branch is your actual environment, and then you don't even need this drift reporter idea. And if you don't set up any checks on your repository, then you could potentially face security issues, non-compliant configuration, not great. So these are some tools that you can use in order to help you in the journey of applying practices enforcement, all of them open source. So I really urge you to check them out and see which of them could be good for you. So to sum things up in this presentation, I talked about several things, but these are the two things that I want you to take out of this presentation. Think about your code-based structure to have Terraform as a platform and to have small state files, and practice enforcement to enable infrastructure and team scaling, because whenever more people use the code, you want to make sure the code is in a high quality state, that people don't abuse it in a way that, let's create resources in the amount of $100,000, right? So practices enforcement can definitely help you with that. And last but not least, remember that another thing that I want to quote from Thyssen Uo article, great article, that programs evolve and code changes, and it is uncommon that you write Terraform code and it stays the same. That's not how projects work. If that was the case, I wouldn't even be here talking about Terraform practices. All of us would just use it the same way, write the code, and continue with our lives. But we will always have projects because businesses want to improve. Changing from the current state to the next desired state is a project. So think about how you structure Terraform codebase and treat Terraform generally, and that way you will allow projects to evolve and get introduced, helping your company improve and contribute to its success and enable infrastructure scaling and your team scaling as well. These are some references that you could definitely check out when you use Terraform, and I really urge you to check them out. Also, the Thyssen article, great article. I know I said it a lot, but it's a very good article. So think about how you use Terraform in order to help you with your infrastructure journey. So thank you so much for joining my talk, and you can stay in touch. You can follow me on LinkedIn or Twitter or whatever you want. Reach out by email, whatever seems good for you. And that's it. Enjoy CelaDB Summit.